I'm back underneath the main chassis now for a second look. There's one problem in particular I want to see if I can resolve, and that is the really poor horizontal sync. I have to fiddle with the horizontal hole control every time I turn the set on. And right away, what did I find? I missed a capacitor. Looks like it's a 0.001 microfarad cap. And what do you suppose it's going to? Well, via these two 470k resistors to the 6AL5, which is the horizontal sync discriminator tube. So what do you want to bet? That's the problem. I've also started checking the resistors, and in general they're all high in value, between a few percent and upwards of 20-30% or higher off in value. I'm only going to change out the ones that are really far, like 50% or more, because that seems to be working fairly well as is. So far I'm going to clip out this guy, 5.6K. It's measuring about 12 or more than twice what it should be. And this big 6.8K is measuring about 10K. A few more areas to check, but so far I'm only going to change out those two resistors. The rest I'll just leave alone for now. There's an issue that cropped up both on the previous 38-1 chassis I worked on and again on this one, which is that some of this wiring is what I believe is natural rubber, which has hardened over the years and is now very brittle, and it's falling off some of the wires. So I had to replace one or two in the other chassis and again in this one. Very similar to the type of wiring I've encountered on late 30s and early 40s Philco radios. What's curious, I think, is that the other wiring under here is mostly cloth covered, which is really sort of a type of plastic on the inner layer and then covered by cloth and wax impregnated. Some of the rubber wiring is still fairly pliable, so I don't have to replace too much of it. Now what I find curious is that on the power supply chassis and on later Admiral TV chassis I've worked on, all the wiring is plastic. So for example, check out the wiring harness on the power supply. This is all just like modern wiring, really. Which modern wiring, I believe they use PVC. I'm not sure what they used back then, but it's in fine condition, bright, colorful, very pliable. So I don't know why they didn't use this for the wiring on the upper chassis. I finished going through the chassis and replaced all the bad mica caps and bypassed the selenium rectifier with a modern silicon diode, replaced 2 electrolytics here, and checked all the resistors, found some that were pretty bad, replaced those. However, I've got a problem. I no longer have video. It sounds alright, but not as good as it had been. So, something's not right. I suspect that the alignment's off a bit now because I changed out some mica caps, and I bet I hooked up something wrong in here. So somewhere in the video IF stages I seem to have lost my signal. I tried using my scope to probe, but I think the signal levels are just so low in these early stages I just wasn't picking anything up. So, a couple things I can do. One is I'll double check my work. I'll pull out the resistance and voltage chart and quickly check these stages. And if I can't find something really obvious, then I'll pull out my B&K 1077, which is currently packed away so I could bring out the 415. What the 1077 will allow me to do is generate an IF signal. And I have the right frequency and polarity and voltage levels, and I can inject it at each stage and work my way back. So I can start with just a composite video right to the input of the video amp, and then work my way back to pinpoint where something stops working. I really hope it's not something inside one of the cans. I was pretty careful. I don't recall damaging a coil or anything, so I'm hoping it's just something really simple. With the help of this resistance chart, I found the problem pretty quickly. V7, that resistance arc should be 10K. I got about 4.5K. That's down in here. It's these two pins. I got basically the same resistance reading on the two, and when I measured the resistance between those two pins, it was essentially 0. But it should be 5.6K. This dotted line here represents that IF can. So what's the problem? Simple. I installed it upside down. So I didn't realize that these are symmetrical. So these two connections need to be flip-flopped with these two connections. So I'm going to disconnect the can again, unmount it, rotate it 180, and then reconnect the leads, and hopefully that will take care of the problem. Ah, that's better. I noticed I get much better sound now too, but only if I fine tune it so that I don't get a picture anymore. So I think alignment is now in store, which I pretty well figured since I messed around with so much stuff. So that's working quite well now. Otherwise, I just started going through the alignment procedure, and something I noticed right away is that I had the audio modulation left on from the last time I used my VA62, and when I plugged in 21.25 megahertz, that's the sound carrier, I had very distinct bars on the screen. What I think that's from is the audio leaking into the video, because the traps aren't adjusted right. And once these first two here, you notice you adjust A1 and A2 for a minimum. A1 being the core down inside, slug on the tuner. So I'm going to adjust that right now via this tool. You notice that the meter drops off rapidly when I tweak it, and also notice that the bars start fading away, becoming less and less distinct. The other trap for sound being this guy up here, so I'll now adjust that one as well. See, that one was also off a bit, so now the bars are even less distinct, and as I go through the other procedures, they should become less and less distinct, because you don't want sound getting into your video. Now I'm using the VA62 to make final tweaks to the set after the alignment. So here's one that shows frequency response. Kind of starts crapping out around 3.5 megahertz, which is the same as I got on the other sets. So not too bad for a set from this era. And the linearity is pretty darn good too. And as for sound, you can hear that tone in the background. Not bad. Alright, so let's try some programming.
Think he can get to Waco that quick? With all the names I gave him, he's a good cop. He was a good cop. Now he's nothing but a common killer. Judge him hard? That's right, I judge him hard.
Channel 3, let's do channel 4 try. Huh, not so good. Let's see. Try adjusting the channel tuning slug. That's better. Alright, now this cabinet needs a ton of work. But I'll save that for another day. For now, I'm happy that it's working electrically.
Can I help you? Oh, yes. I'm here to see Mr. Saunders. Oh, he's up in room 223 over there. You go over the stairs right there. Thank you. Radio for backup units. Take care of the rear. Nobody.
You know, it just occurred to me that there's something I still have neglected to do, and that is replace
Stay right where you are. Don't move. I mean it.
the two can electrolytics up here. Well, obviously they've got some life left because the set's working, but I want to go ahead and replace them, and maybe things will improve a little bit, although not much room for improvement, I think. It's working as well as I expected it to.
I have to finish it, Mike. It's already finished. Give me the gun.
Here's what I did to solve that problem with the 5U4 rectifier tube flashing over on power up. I added a CL90 surge limiting thermistor on the primary of the larger transformer. I couldn't do both because this set draws about 2¼ amps total, and this is only rated for 2 amps max. I tried putting it initially on the output of the rectifier tube, in other words between the rectifier tube and the first filter cap, and although that seemed to work, it works better on the primary because this device is actually supposed to get pretty hot. It wants to have like an amp or more running through it to achieve its operational temperature, which lowers the resistance of it quite a bit. There's not that much current flowing from the B+, relatively speaking. It's, I don't know, a couple hundred milliamps, something like that. Significantly less than there is on the primary, that's for sure. Now, the operational temperature of this is pretty darn hot. So I mounted a clear away from everything. In fact, there just happened to be, conveniently, a pre-drilled hole that wasn't used for anything on the chassis right here, and there's nothing else around here. This is fairly well enclosed. When it's in the set, there's a piece of wood that covers the bottom, but this is not much ventilation. However, the whole thing is metal, so the heat travels upwards and hits this metal, and the metal gets warm, and it does a pretty good job of just conducting the heat out. You know, it's like a giant heat sink. So I'm not too concerned about any, overheating problems or anything like that. I suppose there is one minor downside to adding the thermistor, and that is the set takes longer to turn on. But we're just talking about, I don't know, 15 seconds longer, something like that, if it's completely cold. So I'm going to turn it on now. You should notice a difference, is that the smaller transformer, the 5Y3, will light up faster than the 5U4. Because remember, the thermistor is only on this side, not this side. So 5Y3 is already glowing, and the 5U4 is just coming online there. So see it? Nice slow, soft startup, no blue arcing over.
Streets of San Francisco, a Quinn Martin production, starring Carl Malden, also starring Michael Douglas.